Hi, everyone. Who here is a JavaScript programmer? Who here is from Yahoo? All right. More Yahoos than non-Yahoos. All right, so my name is Philip. I work with the Paranoid team here at Yahoo. We do security stuff. I also do a bunch of performance-related research. I have been doing for the last 3 years or so. So this talk is more about the performance research that I've done over the last 3 years and the tool that's come out of that research. If you need to reach me or tweet about me, that's my Twitter handle is bluesmoon, and my email address philip@bluesmoon. Right. So who here has heard about Boomerang? All right, cool. Who here knows what it does? What are you doing in this talk? Right. Who knows what this is? Cool. So that's Firebug NetPanel output for the Yahoo homepage. And what does it tell you? What does this first screen tell you? The progress of the page, how much time each component took to download, how much time was spent doing DNS lookups, connection, TCP setup, actually downloading the content. What can we tell from this? There's a bunch of time when the server's doing stuff and the client's doing nothing. Right? The server's generating the page. The Yahoo homepage is a PHP page. It's got pull the content from various places. So it's building this page. So that's time the client doesn't do anything. It can't download anything because there's nothing to download. And it can't start downloading components because it doesn't know what components to download yet. So that's something that happens on the server, something we can tweak as much as we can, as much as we want to. But look how far after that. So that's 414 milliseconds there. And this here is 3.82 seconds when the client actually finishes loading content. Right? Of that 414 milliseconds is the only time that's our server is actually doing some work. Everything else is the client doing something. And that client is something we don't have control over. Right? We can't measure that in the lab sitting at our desktops. We need to know what each user's client does and how long it takes to download. Now, what's it actually doing during that time? Waiting? Yeah, it's not really waiting. I mean, it's doing a bunch of things that actually goes down all the way there. But it's downloading a lot of things, but look at what it's doing, right? It spends some time doing DNS lookups, 103 milliseconds for the home page, probably the same for other components as well. It spends some amount of time to connect. It's just opening a TCP connection. So every connection needs to open, takes some amount of time. And it spends some amount of time receiving data that depends on the bandwidth of the user, right? So those are three things that actually depend on the client itself. How long does it take to do a DNS lookup, open a TCP connection, and receive data? Three things that we can't control on the server side. So less than 20% of that time, if you look at that, 414 milliseconds out of 3.82 seconds is time that we can control and fix during development in terms of actually doing performance testing on the server side. Right? There's that remaining 80% that happens because of client characteristics. Different browsers deal with connections differently, deal with pages differently. Users have different kinds of connections, and all of that is something we can't control. Right? And that's what bites us. That's what's taking up most of the time. That's what we want to improve. In order to improve it, we first need to know how much time it takes. And why is it so hard to control it? It's because users have different browsers. Each browser has their own plugins installed, each of which changes the performance characteristics of that browser. They run them on different operating systems. Each operating system has its own viruses installed. Some of them also have antiviruses installed that also mess up with performance. Like, for example, turning off gzip compression because they don't want to deal with un-gzipping before scanning for viruses. Microwave ovens and other things that emit microwaves that interfere with wireless modems. introduces packet loss, which in turn affects the performance of your page. I actually have this problem at 8 p.m. every day when people start heating up their dinners in my apartment complex, and I get huge packet loss. Baby monitors, same wavelength as your wireless modems. And naughty neighbors who crack into your users' wireless modems and start stealing their bandwidth. File shares. Governments that put in proxies and run all data through that. Rodents that eat network cables. And how do you simulate all of that, right? Each of these things adds a new variable, and if you have to tweak all of them on and off, some of them you can't even get far enough to tweak on and off. How do you get all of that in the lab? How do you get a realistic understanding of how fast that page is loading for each of your users, right? We can use Firebug's NetPanel to find out how fast it takes to load on our desktops sitting in our right next to our servers. So that's probably the best download time that you get. Right? That 3.82 seconds was running from right here in Yahoo connecting to a Yahoo server. It's probably the best time it takes to download a page. Right? And there are probably people who could get better, but for the most part, that's the best. So what's the worst? That's not something we know. Right? And that's where Boomerang comes in. So we need to measure this real end-user performance, and we need to measure it from the end-user's box. Any ideas how you'd go about doing that? Boomerang. What if we hadn't released Boomerang? What would you do?
You could do a Boomerang browser extension.
How do you get users to install that?
Find an old computer and try to run it from that.
Well, an old computer is still not going to... You need to put it on an old network or a really distant network. Or one way is to actually build an extension and ask users to install it, right? That may work, but it's not necessarily representative. You only get the users who would opt into something like this, not the users, not the general sampling of your users, which means you don't get a good enough idea of what all your users experience. So the next idea we had was why not do it in JavaScript? JavaScript is on almost every browser, right? 98% of browsers that users that visit Yahoo at least have JavaScript turned on. Most of the pages that we want to measure actually use a lot of JavaScript. So we're actually measuring things that already have JavaScript on them. So we do actually have JavaScript. The problem is JavaScript actually, before I get there, JavaScript adds page weight to the page, right? Every time you add more JavaScript, it increases the weight of the page. And that's your basic Heisenberg uncertainty principle. You can't measure something without actually changing what you're measuring. Right? So when we add JavaScript in, we change the page weight, but we assume it's going to be small enough. We try to make it small enough to not affect time too much. And that's where Boomerang comes in. A piece of JavaScript that sits on your page and measures the time it takes to download your page from the end user's point of view. So it basically measures the time from the user clicking on a link or entering a URL to the time that page actually loads up. How do you define the time when a page has loaded up? Sorry? Is that true for all pages? No. Right. So for most pages, it could be when onload fires. For some pages, you may actually load content after onload fires. Some pages may have loaded before onload fires because you're loading invisible content later. So we actually leave it up to the developer. By default, we say when onload fires, that's when your page has loaded. Right? I'll get to that in a bit. So let's jump straight in. How do you actually include Boomerang on your page? Well, you need to get boomerang.js. That's the JavaScript file. It's, I think, 20 kilobytes, 28 kilobytes minified. No, not minified. 28 kilobytes in total, 4 kilobytes minified and gzipped. So it shouldn't add too much to your page weight. You include it on your page and then initialize it. Tell it your user's IP address, and I'll get to that in a bit, why we actually ask for the IP address. It's not mandatory. And the beacon URL, that's where you want to send your measurement results back to. Right? So there's no point actually measuring and then throwing away that data. You want to actually send it back to your server and do something with it later on. So that's what the beacon URL is used for. Right. And coming soon, you're going to be able to do something like this. I'm actually working through unit tests at the moment, which is always the longest. So basically, there's a gallery module called Gallery Boomer. It's not yet in YUI Gallery. It's in my fork of YUI Gallery. And call it exactly the same way. So what does it do? It does three basic things. First, measures the user's bandwidth and latency to your server. So well, technically, it measures it to where you want to measure it, but by default, that would be your server. Measures the current page's load time, so the time from the user initiating a page request to the time the page actually is available for the user to use, and sends these results back to your server, right? Using standard beaconing techniques. So I'm going to actually throw up a question now. We can do this talk in two ways. I can tell you how Boomerang does the things it does, or I can tell you how you want to use Boomerang. We may not actually have time to do both, but if we do have time when we finish one section, we might jump to the next. So which do you want to do first?
First one, internally.
How does Boomerang work internally? Good, because that's the next slide. Otherwise, I'd have to click with the mouse. Right, how does Boomerang work? Why don't you guys tell me how you'd build Boomerang if you had to? So how would you do the latency measurement? Let's go back here and see what it does. So how would you do latency measurements?
Set up an event on before unload, set a cookie
All right.
with the Unix time, and then check that on the next page.
All right, that's the total page. I just want to know latency. How much time does it take to ping from the user's box to my box? Or something similar. Ping with XHR? Image tag. All right, scripts. So I don't use XHR because my beacons may be on a different box than I may be hitting the CDN versus my page actually being on the home. Scripts, yeah, I need to use JavaScript, but I use an image tag, right? So I use an image tag and attach to the onload event of that. So let's go forward. Right. So what we do is download a 32-byte GIF 10 times, one after the other. Why 32 bytes? Sorry? Well, I could have done 0. So that's actually the smallest image possible that will fire an event on every browser. A 0-byte image is fine, except it fires neither an onload nor an on error on Symbian's WebKit implementation. So the 0-byte worked everywhere except on that browser. So like 32 bytes, 0 bytes, still one packet. So, all right. So 32-byte GIF downloaded 10 times. Why do I do it 10 times? Just to increase the accuracy, and it shouldn't take too much time to download a 32-byte single TCP packet, right? So measure the time it takes to download each. Throw away the first measurement. Throw away the first measurement because it required a DNS lookup, probably required a DNS lookup. It also required a TCP connection setup, right? The remaining 9 images go over the same TCP connection, so they don't pay that initial price. And I just take the arithmetic mean of those 9 images, and that's my latency. Now, it's important to note this is not the ping time. This is the HTTP latency. So it includes the time it takes to set up a TCP, well, not to set up a TCP connection, but to send a TCP packet and get one back, and for the application layer to deal with that, right? So it's a little more than the actual ping time. I measure the arithmetic mean, standard deviation, and margin of error. The reason for the other two is basically to find out how accurate my measurements are. On really bad networks, you might have a lot of differences between the different latency measurements. But for the most part, that should be the right thing. So yeah, like I measured, first image might require DNS and TCP. We don't worry about slow start in this case. Does everyone know what slow start is? All right. So slow start is basically when you first open a TCP connection, both ends assume that the other end can't deal with the connection as fast as possible. So it starts with a small window size, which means you can send 3 packets or 2 packets before you expect an acknowledgement to come back. Right? What that means is if the 2 connections are really far apart, you're going to send 2 packets and then just wait doing nothing before an acknowledgement comes back. And we don't worry about that for this particular case because our entire payload is in 1 packet. Right? So it's going to send 1 packet and get a response back whenever the response comes. Now, what happens when you send multiple packets over the same connection and you always meet the acknowledgement requirement? Both ends say, okay, I think this connection can handle more data, so I'm going to increase the window size and now send 10 packets before I require an acknowledgement, or 20 or 30 or so on. So by doing 9 images or 10 images, we're actually doing a lot to improve that TCP window size. And that's when we come to bandwidth. Before we get there, who wants to guess on how we do it? Sorry? More images. Right, because we love images. What would we do with more images? Larger images. You know it. You can't answer. You're disqualified. Right. So what we do is after the latency test is done, we download progressively larger images. We start with an 11 kilobyte image, and we go on up to 110 megabyte or 600 megabyte image. Right? Depending on how fast the user's connection is. So the first image to timeout, we time out, each image has its own timeout value, typically between 1.1 and 1.3 seconds. The first image to timeout is the largest image that can be downloaded on that user's connection and saturate the network. Right? So if the user has a really slow connection, they'll probably time out on the 11 kilobyte image. In my measurements, 14.4 modem to 36K modem is what's going to time out on that particular image. As we get larger, someone with a T3 connection will probably go up to the largest image. We typically see people going up to 20 megs or something before they actually saturate. So once we find an image that saturates the network, we stop downloading images and we re-download that largest image 3 more times. A few more times. You can actually configure it in Boomerang. The default is 3 more times. And now we have 3 measures of the largest image. We calculate the median, standard deviation, and margin of error for that. And in this case, it's not the arithmetic mean, it's the median. Thing we find here is that because this image is much larger, there's a bigger variance in the actual download times. So the same image downloaded 3 times will can take very different amounts of time to download. Mainly because the network is not really, the network downloads are not really linear. It happens in different bursts. So we get an order of magnitude of how close the user's bandwidth is. And once we do that, we have how much, basically the kbps of that user. Now, like I said initially, by downloading those 10 latency images first, we increase the TCP window size. So your bandwidth images are not paying the price for, well, they get the best use of your network connection. Again, doing progressively larger downloads of bandwidth images means the first few images all fit into the TCP window size, right? Right. How do you measure page load time? I'm not going to ask you this. So quite simply, attach an event to on before unload and to onload, and measure the difference between them. Now these 2 events fire on 2 different pages. Right? On before unload fires on the page the user clicked a link on, whereas onload fires on the page that the user clicked to load. So what we do is, when on before unload fires, measure the time and store it in a cookie. We also store the URL of the page that the on before unload fired on. Right? Store both of those in the cookie, and then when onload fires, check the cookie, get the start time out of that, measure the time difference. We also make sure that the URL stored in the cookie is the same as document.referrer. Right? Any guesses on why?
Coming from a page that's not yours?
Good. So the main reason, yeah, there could be redirects, or let's say the user came to my page, clicked on a link, so that actually set the cookie, but they clicked on an external link, not one that went to my own page. So they clicked on, let's say they were on bluesmoon.info, they clicked a link which took them to news.yahoo.com, and then they typed in bluesmoon.info again. So now it comes back to my page, onload fires again. The cookie is still valid, right? So I'm going to measure the time from my page to news.yahoo.com back to my page, which is more than I should. So by using the referrer, I make sure they've actually gone from page A to page B. Right? Any questions? Yeah.
Is on before unload fire in Opera?
Nope.
Yeah, that's
So what we do on Opera, we actually attach to on before unload and onload, and on unload. And the first one that fires takes off the other one. Right. So it'll fire regardless of the browser. It'll be a few milliseconds off on Opera, but we don't care.
Yeah.
Who uses Opera? So you can also, I mean, you probably know like what browsers your users use, so you can adjust your tests accordingly. Right. So why do we need 2 pages? Right. This is a problem because the user may have come from a page that we don't own, so we can't actually set an on-unload or on-before-unload handler there. They may have typed in our URL in the browser. They may have clicked on a bookmark. There are various ways. They could have clicked on a link in Instant Messenger and email, none of which will actually have an on-before-unload handler or set a referrer. So what do? We use the web timing API. If the cookie doesn't exist, we try to use the web timing API. Who here knows what the web timing API is? Why don't you tell us?
Relatively new API for doing timing. I mean, it's everything from JavaScript intervals to
Right.
actually load timing.
Right. So I'll repeat for the camera. It's basically a new API. It's actually not yet standardized. It's still in the draft stage. That's basically creates a performance object within your browser and says, this was a time when these different events happened, which includes the time the previous page started unloading, the request for the current page started, DNS time, connection setup time, and all that kind of stuff. As of today, the only browsers that support it are Internet Explorer 9. Who would have thought? First browser to support web timing. Chrome, and that's it. Firefox is rumored to be adding support in 4 point something, but I haven't seen that yet.
Chrome,
And
but not Safari.
sorry?
Chrome, but not Safari.
Not Safari. So Chrome actually had an older version. The guys from Google actually made the proposal to the W3C. So they actually had an older implementation in older versions of Chrome that it had a completely different API. It wasn't documented. So we actually looked through the source code of old versions of Chrome and also have support for that undocumented API. The new versions all follow the documented API, except each browser has its own prefix, so it's MS Performance, WebKit Performance, and I also put in Firefox Performance just in case Firefox happens to support it. No word from Opera yet whether they're going to support it or not. And I think those are the major browsers, or at least browser engines. So if the user's browser happens to support that, we'll get data in from there. We don't know yet if the data that we get from the web timing API is going to match the data we get from on before unload. So we're currently betting that it is. It may not be, in which case we'll probably want an identifier in the beacon saying we got this data from web timing and not from the cookie. Right? But that's not in there yet. And if anyone wants to add a patch, feel free. Right. How accurate it is? Latency is pretty accurate. So we get it within 1% of, well, I won't say the actual value, but all the different measurements that we get are within 1% of each other. So that's fairly good. Bandwidth, not so accurate, plus or minus 30% on a really bad connection. It doesn't get better than 10%, so it's still not kind of margin of error that you want, but it gives you an order of magnitude. So you could say whether this, and also knowing different standard connection speeds, you can sort of group the user into different blocks. So say this user has bandwidth below 200 kilobits per second, or this user is between 200 and 1 megabit, which is a fair enough block, and 30% fits within that block, right? And so typically at Yahoo we look at, we have 6 different blocks, but we only care about, well, we merge them into 4. So I think it's 0 to 200, 200 to 800, 800 to 2 megs, and 2 megs to 6, and 6 and above, right? So depending on the actual country in which you're measuring page load time, you may have to tweak these blocks a bit. So for example, you go to Hong Kong or Korea, there's nobody in the 0 to 1 megabit range, right? You get 0 data points there. Everybody is 1.1 to 2 or even above 6. Whereas you go to India or Indonesia, Malaysia, you find everybody's in that 0 to 800 kilobits, and very few above that. Right? So it may make sense to actually tweak how you handle your data based on which country you're measuring the data for. Page load time follows a distribution, what we call a log normal distribution. Does everyone here, who here knows what a log normal distribution is? Right, so who knows what a normal distribution is? Right. Normal distribution is your standard bell curve. Right? Log normal basically means if you take the log of the x-axis, it follows a bell curve. So rather than plot the actual x-axis, you plot the log of the x-axis. So you will actually get something like that with a very long tail. Right? And sometimes that tail can be much further out than your actual median. So what you want to do is do some kind of filtering to say, I'm only going to look at this data before I decide what my actual value is. And everyone else is an outlier, probably because their DNS server failed or something like that. Right. Does anyone want to know about DNS failures and stuff? So that's actually something we noticed a bit. Every now and then a DNS server fails, and DNS timeout is typically 30 seconds. So let's say a user has the ISP gives them 3 DNS servers, and the one they hit first actually fails. It's going to wait 30 seconds before it times out. So your page load time is going to be 30 seconds longer. Right. Yeah.
Doesn't it fail over to a second or third?
Yeah, but after 30 seconds.
Okay.
So it will actually succeed. Your events will all fire, but all 30 seconds later.
What's
So,
the failover just between different feeds?
no, say that again.
So if you have 2 or 3 DNS servers,
Yeah.
what's the failover just between one to go to the secondary?
Yeah, so this is on the ISP level, right?
Yeah.
So it's basically the browser or the client's resolver hits the DNS server, waits for it timeout, and only then hits the second one.
Oh, okay.
Right.
So you're saying that's 30 seconds between each one?
It depends on how it's configured. By default, it's 30 seconds. Anybody know different? No. Right. So that's basically what happens. Now, okay, I'm going to skip over the using Boomerang section and go to the kind of data and what we do with the data. Right. The beacon. How do you actually deal with the beacon? So we calculate all this data, we send it to you. What do you actually do with it? So how do you handle it? What we do is we send a GET request to the beacon URL. So that URL which was mentioned in the init function, we make a call to that and make a GET request to that, passing all the parameters as query string parameters. Right? There's a bunch of parameters. There's the tdone, which is the time it took to load. That's the default time. The URL of the current page. The referrer, in case it was different from the previous page. And there may be valid cases for that. Right? And any other timers you set. So I haven't mentioned any other timers because that's in the using Boomerang section. But if anyone's interested, you can ask me. Right? And in JavaScript, we also fire a before beacon event that you can actually attach to and decide to do things within that page itself based on the load time. So for example, you may decide not to download some expensive images for the next page, or CSS for the next page if you're doing preloading for the next page. Or you may decide to add additional functionality if the user's connection is fast enough. So there's various things you can do in JavaScript if you already know the time it took to load that page. But for the most part, you might just care about collecting data and doing something with it later on. So what should we do? Well, the first thing we need to do is sanity checking. There may be fake data. Right? What kind of fake data? Yeah, I mean, crawlers something that you filter out anyway. So let's ignore crawlers now. Right? There's you could have tests running, so your developers may be testing. So you want to filter out maybe your internal IP addresses. You could have data that just seems absurd. Right? For example, a page load time of 3 milliseconds. Right? Happens. Page bandwidth of 4 terabits per second. Right? It's also data I've seen. User agents that make no sense. What else? Abusive data. So somebody sees that URL on your page and says, hey, I wonder what happens if I hit it 10,000 times. Or try and XSS a beacon. Happens. Or just rate limit. Sometimes a person's just a particular page is just getting hit too often because it's become so popular. And your beacon server can't actually handle the load. Right? So you have a page, you have 10 servers behind your page, but you have only 2 servers behind your beacon. So you want to throttle the beacons that actually come in so that you don't overwhelm your beacon server. Right? Then you want to do some kind of statistical analysis. So typical analysis would be taking out outliers. There's typically 2 ways of removing outliers, one of which is a simple band filter. So you say any load time that's below 50 milliseconds or above 2 minutes is something I don't care about. Right? It's something that's too absurd to care about, so I'm just going to throw that out. The other is based on the actual data. So you do something like interquartile range filtering, where you say, if my median is this, and my first quartile is this, and third quartile is this, I'm going to take only data that fits between this particular range, which is called the IQR. Right? And I'm not going to go into IQR here. There's a good article on Wikipedia. Read it up. Right. So take out outliers so that you only have valid data left. Aggregate based on bandwidth blocks. So we have users put into different bandwidth blocks. It doesn't make sense to compare your slowest user's load time versus your fastest user's load time. So you make these different blocks and only calculate load time within them. So you may have 4 different load times, 6 different load times, depending on how many blocks you have or which country you're serving. And then based on how many users you have from each block, you can decide whether you actually need to improve performance for that page or not, right? Or how much effort you need to put into improving performance for a particular page. And then finally, measure trends over time. So you measure load time every day or twice a day and say, okay, on this day I made a push. Did it actually improve performance or worsen performance? Right? What else would you do with the data? Yeah.
And this is completely up to the user.
Yep. So we haven't built anything available to the public yet for that. There are plans, but they just remain plans. So measure trends over time. What else would you do with the data?
You can probably correlate it to the number of page views per session.
Right.
Somehow convert this into number of dollars per user based on how much bandwidth.
Pretty cool, yeah. So that's actually a good point. If you can actually correlate your performance to a monetary value, you can probably get funding for improving performance, or get a speaking slot at the conference. Bandwidth blocks. This is a measurement we did back in February this year. We looked at different connection types and the actual bandwidth they offer, and the number of users you get for that bandwidth. So the y-axis is the number of users. The red is latency, blue is bandwidth. We see that cable and T1 connections have the highest bandwidth and lowest latency. Also the x-axis is the actual value. The number of users is not listed in here. So just looking at this kind of data, you can figure out what your different blocks should be. I should actually have shown number of users versus block, which would have given you a better idea of what your bandwidth block should be. So my mistake. Geographic data. So this is another interesting thing you can do with your data. If you see your load times from different geographic locations, it could tell you where you want to put your next mirror or where your CDN points should be. In our tests for the YUI blog, we found that having one box in the US East Coast can handle both US East Coast, West Coast, and European traffic, but not Asian traffic. So you want a box on the US East Coast and somewhere in Asia, maybe Hong Kong, to handle the whole world, right? But it may be different for your individual site depending on where your users come from. So that's a good metric to look at. You can also group data by ISP. So a typical way to group by ISP is just, the simplest way is pick the subnet and say, okay, everyone in this subnet is from an ISP. Or you could do more detailed analysis and group by ISP and find out who's behaving badly. Like, has somebody's DNS server down? Or is a particular country filtering data? Something like that. More data. So you can do much more. You can also write plugins for Boomerang. How much time do I have left? Is it 15 minutes or 0 minutes? 15 minutes. All right. I might actually be able to do the using Boomerang section then. So more plugins that we're thinking of. We already have a DNS plugin that's written by Carlos Buena from Facebook. What it does is try to measure how much time it takes to load, to do a DNS lookup from the user's browser. It measures worst case scenarios, so not the average case, but assuming the data is, the DNS record is not in any cache anywhere along the way. How long would it take to do a DNS lookup? Thinking of IPv4 versus IPv6 and full web timing API, time it takes to do connection setup. Does anyone want to theorize about how we do this? Yeah, web timing API, I mean, assuming it's available, it's pretty simple. Just, I guess just JSON encode the whole thing and send it through in the beacon. Right?
Does that include connection setup?
That would, yes. What about if it's not available? So how would I do IPv6 versus IPv4 and connection setup time? Yeah.
Could you look at the difference between the measurements from those 9
Yeah.
secondary images
Right.
compared to the first?
Yep. So something almost exactly like that is what I've been thinking about is, but instead of doing 10 images, I was thinking of doing 12 images in groups of 3, so 4 images in parallel. Right? The browsers do, well, except for Internet Explorer 6, all browsers do at least 4 connections in parallel at a time. Since they're one packet each, they're not going to saturate the bandwidth, so download time is going to be the same. So download 444. The first 4 pay the price for TCP connection setup. The next 8 don't. So take the average of those 8, the average of the first 4, and that may tell you the difference. Except the first one also pays the price for DNS. So do we take 8 versus 3 and then 1? Oh, I don't know. It's just floating around in my head. Yeah. Yeah. Right. So it's just that having just one data point for DNS means you can't do a margin of error. Margin of error in a single measurement is 0. So it could be 100% off, but it's still 0. So yeah, IPv4 versus IPv6 is not too hard, but requires a lot of playing around with DNS to make sure one host name only resolves to IPv6 and another host name only resolves to IPv4. But none of that is written. It's all up for grabs. If anyone wants to write the code, go ahead, fork it on GitHub, write the code, and send in a pull request. You can do anything with it. So let's jump back to using Boomerang.
Actually, I have a question.
Yep,
before
go
we
back.
skip back over. I'm really curious what the page impact of the bandwidth measurement is.
Okay, so bandwidth measurement is done after onload files, or rather after you say that my page has completed loading. So we assume that at that point of time there's nothing downloading. Now you may be preloading content for the next page, in which case it will contend with it. It won't block rendering.
Does it interfere at all with user interaction? I mean, if you got some JavaScript that's going to be, responding to events and stuff like that, is it going to, is it not going to respond to events versus wallets in the middle?
No, so the JavaScript itself executes really fast. The time it takes is basically browser blocked on an image load. So JavaScript events still fire during that time, and everything else goes normally.
Has any thought been given to how this might impact people who are accessing on a mobile plan and they have a limited
Right.
data plan?
So
Making it down possibly megabytes.
So the best thing we suggest for that is to disable Boomerang for that. We don't serve it out to 100% of our users. That's just too many beacons. So we typically pick 1% or 2% of users. Depending on how many page hits you get per day, you may want to tweak that. You may also want to decide not to serve it at all to some people. Now, an additional thing you can do is turn off bandwidth measurement for certain users. So you could, for example, detect that this user is on a mobile connection and turn off bandwidth detection. So it's basically say this plugin is disabled at that point of time.
That toggling for selected users, that's to be handled on your own server side. There's nothing in the actual.
So somebody actually submitted a patch to do random sampling within Boomerang's JavaScript itself. My personal preference is to do it server-side so that people who are not in the sample don't have to download the code. But it's up to you. You may not have the server-side support to do that. So the random sampling is in core Boomerang. It's not in the gallery module of Boomerang yet, I should say. Any other questions?
What's the best practice to make it Intel aware?
In what sense?
So I mean, would I pass the Intel from the markup into a config, an argument?
You could. So Boomerang allows you to add as many parameters as you want to the query string. Just add tags saying this page. I mean, you could do A/B testing. You could have the Intel value. I'd more likely detect the Intel based on the user's IP address, assuming that's how you're detecting it in the first place, since the beacon's going to have the same IP address. Right? But if not, if you're doing something else to detect it, then yeah, you could store it in the beacon. You can store any amount of things. So the most common use case is actually doing A/B testing. So people specify a tag saying this page was generated with these parameters. Right? And they may have many different tests running in parallel. Anything else?
Is there a way to test how long different parts of so that you can say, for instance, can I test how long different loading strategies for loading a boilerplate?
So that brings me to this section. All right, so using Boomerang, I've already mentioned this, and it's probably good enough for most people, but you want to do more, right? I thought of you. You could handle subdomains, so Yahoo case is pretty common here. We have everything.yahoo.com, right? So a cookie set on something.yahoo.com is not going to go to something else.yahoo.com. So we set the domain to just be yahoo.com, and you may want to do that as well. Now, this lets you measure across. Now, you want to measure just more than just load time. For example, how long did it take the head to load? How long did it take this initial section of the page to load? How long did it take ads to load? How long did it take the footer to load? So there's two ways of doing that. In my slides, I only mentioned the second way because the first way requires you to load Boomerang at the top of the page, and we all know that's bad practice. So you store different timers in JavaScript variables. So tPageStart is equal to new date.getTime, some content there, then th for thead, and the variable names are small because that's how they fit on this page. And tj for something else, and so on. And then at the end, when I actually, after initializing Boomerang, I can say boomer.plugins.rt.setTimer and all the timers. There's actually a dot here, which can't be seen. And that's it. When you do that, all of these are beaconed back. It adds all of these to the tOther field. Right? So thead, tbody, tjs are added as a comma-separated list in tOther. The reason we put it into tOther is because we don't want someone to override tdone. Right? Again, how to actually pull it out is all documented in the how-to documents, so I won't go into that in detail. So that's one thing, measuring different parts of the page. You may also want to measure dynamic content. So let's say the user clicks on a link, it doesn't load up a new page, but it pulls in content using XHR. So how do you measure the time it takes to load that? What you could do is set auto run to false in Boomerang. That means it won't actually attach to any to the onload event. It'll expect you to fire the event when you think it's ready. And then just before your download starts, you start the timer. So you say start timer tdone, which is that actual download timer. In fact, you could use any timer you want, but the default is tdone. And then just after it's loaded, you call the done event. So say, I'm done now. Go ahead and measure the time and beacon it back. And you could do this for every download that happens. Start the timer, fire done. Start the timer, fire done. And there's much more you can do. So there's a whole bunch of how-to documents. I think 8 how-to documents, 9 if you consider they start at 0. And explains a whole bunch of things and how you can do things with Boomerang. Right. That's the end.